The sixth lesson in kinematics is called Uniform Accelerated Motion. And the guiding question for this lesson is, what are some mathematical expressions that we can derive to relate the properties of an object's motion? I want to start with a disclaimer. I'm going to show you how we can take the three equations that we already know and manipulate them and combine them to form three new equations so that we can see different ways that displacement, velocity, acceleration, and time are related to each other. And these equations are very, very important. But what's not super important is that you fully understand where they come from. You certainly don't have to be able to recreate these derivations on your own. I think it's something that's important for you to see. So don't write down anything that isn't in a blue box. You'll see. And if you don't understand every step of the way, don't worry about it. Okay, just try to follow along the best you can. Write down the equations when they get boxed in blue, and then we'll use the equations in class, and you'll see how they work, and that's what's really important here. Okay, so let's start with UAM equation number 1. We've seen this equation before. This is A equals delta V over T. And this one's easy. We're just going to rearrange this equation a little bit. So let's multiply both sides by T, cross multiply in other words. And then we're going to add the initial velocity to both sides. And that's it. I want to rearrange this so it looks better. But that's what we end up with. VF equals VI plus AT. This is not even really a different equation than A equals delta V over T. It's just rearranged, but it's a good place to start. All right, on to UAM equation number 2. I hope that you recall that there are two equations for average velocity. D over T and VI plus VF over 2. And since they both equal V average, we can say that they equal each other. If A equals B and A equals C, then B equals C, right? So let's do that. Let's set these two equations equal to each other. And now let's multiply both sides by 2. And so we end up with the 2 over here. And then let's subtract VI from both sides. And I want to do that so that we get the VF all by itself, because we just learned an equation for VF, right? VI plus AT. So we can replace the VF on the right with VI plus AT, right? And we want to get rid of VF. What if we're looking at a situation where an object is accelerating from one speed to another, but we don't know how fast it ends up going, but we still want to know maybe how far it goes? Right? We've gotten rid of VF. That's our goal. So now let's combine the VI's by adding a VI to both sides. And I don't like that T in the denominator, so let's multiply everything by T. So we get 2VIT plus AT squared now. And let's get rid of these 2's. Let's divide everything by 2. So those 2's go away. And now we're just kind of cleaning up a little bit. We get D equals VIT plus 1/2 AT squared. That is UAM equation number 2. Okay, on to the final one. Okay, so we'll start with this equation again. A equals VF minus VI over T. And let's take a look at rearranging this a little bit. So let's multiply both sides by T, or cross multiply. And then let's actually divide by A. Right, I want an equation for T. In this case, T equals VF minus VI over A. And now let's look at UAM equation number 2, the one we just found. This is going to look ridiculous. It looks terrible. Just follow along. UAM equation number 2 has 2 T's in it, and now we have an equation for T. Right? We could replace any T we see with VF minus VI divided by A. And that's exactly what we're going to do. We're going to take that whole term and replace the T's with VF minus VI over A. So those are going to go in right there. And that's going to, that looks like this. All right? And we're going to clean this up. We'll just get right into it. Let's distribute that VI into the VF minus VI, and let's square that term on the right. Okay? So when we do that, we get this mess. Don't worry, we're going to clean this up. Look at the term on the right. We have 1/2 A, and then we have over A squared. So the A and the A squared, one of the A's and the A squared cancel out. So that's cleaner. And now let's multiply the whole equation by A. So we get an AD on the left, and those A's in the denominator disappear. That's a little bit cleaner. Okay? Let's get rid of the 1/2 so we can break that term out of the parentheses over there. So to get rid of 1/2, we could multiply everything by 2. All right, so every term is going to get a times 2, and the 1/2 disappears. This looks terrible, but look at this. We have a positive 2 VIVF and a negative 2 VIVF. Those are gone. Okay. Also notice we have a negative 2 VI squared and a positive 1 VI squared. We can combine those. Right? That becomes just negative 1 VI squared. We're almost done. Let's add that VI squared to both sides. And now we're done. We're just going to rearrange this. We get the equation VF squared equals VI squared plus 2AD. That is our third UAM equation. So I hope you've written all these down. Let's summarize. Right, we have 3 UAM equations. VF equals VI plus AT. D equals VIT plus 1/2 AT squared. And VF squared equals VI squared plus 2AD. We're going to talk more about this in class, but notice the first equation does not include displacement. The second equation does not include final velocity. And the third equation does not include time. That's going to be very important.